And we are recording. Welcome everyone to SQL Friday. This is number 18 already. Our star for today is Gail Shaw, presenting in the same time zone as me, which is very rare. Usually we're some hours away. Gail is going to talk about transactions and atomic operations. Gail, over to you.
Awesome. Greetings, everybody. Good day, and I'd say welcome to Johannesburg, but Johannesburg's not very welcoming today. It's cold and decidedly miserable. Kind of looks like Europe, actually.
Can I just mention, if someone came in late with questions, do not unmute yourself. Type questions in the chat because it will be very chatty if everyone talks. So type your questions in the chat and I will relay them to Gail on a good occasion. May not be immediately, but in a while. Sorry for the interruption.
That's fine, not a problem. All right, so I'm going to be talking about transactions today. Now, before we start, I should warn you that this is a fairly basic presentation. I generally put this at level 100 when I'm submitting it to conferences. That said, I don't recall a single time that I've given this that I didn't have at least 2 or 3 people in the room going, "Oh no, really? Is that how it actually works?" at some point during the presentation. I haven't quite had somebody run out of the room to go and fix something, but I have had several people going, "Oh dear, I have work to do on Monday," after one of these at SQL Saturday. So, introductory is not, it's not something that you're all going to know. So I just need to kill that for a sec. Sorry about that. No, that you don't want that. You want that. All right. So yes, transactions. Let's get some definitions out of the way first. A transaction in a relational database is a boundary of a unit of work. This unit of work, by relational database rules, is an atomic operation. It also has several other properties. So we will consider this unit of work, this is a chunk of something that needs to be done on the database. This can be one data modification statement. It can be 20 data modification statements. It doesn't matter. The transaction is what bounds this into a single unit of work. By relational database rules, a transaction completes entirely, or it does not complete at all. Meaning that if the transaction completes and commits, the changes made during that transaction are part of the permanent database state. If the transaction does not commit, if it's rolled back, if it's never completed, those changes never happen. It is as if those changes have never happened. By all mathematical rules for relational theory, a transaction which rolled back should have absolutely no effect on the database, should never have been visible, should actually essentially not have happened to the point of view of anybody outside. This is theory, this isn't reality. Reality isn't quite so clean as this, but this is the theory of transactions. For a unit of work to be considered a transaction in relational databases, it must exhibit 4 properties: atomicity, consistency, isolation, and durability. And if you've seen the abbreviation ACID for relational databases, the ACID properties of relational databases, this is what they stand for. Take a moment and go through what these mean. Atomicity means that the unit of work, the transaction, is a single, behaves as if it was a single operation. All of it happens or none of it happens. You cannot have part of it happening. So if you've got 3 data modifications in a transaction, that transaction is atomic. Those 3 data modifications occur, and the end result is that all 3 occurred, or they do not complete, and the end result is as if none of them had run. Not 1 or 2, none. That is what is required for atomic. A statement or set of statements that cannot be broken down. Consistency. This property requires that once a transaction completes, whether it completes successfully or whether it rolls back, the database must always be in a consistent state. The non-clustered indexes must have the right number of rows in them. All the internal structures must be correct. All of the secondary structures in terms of non-clustered indexes and views, index views, those kind of things must be correct. You cannot ever have a situation where if you look in a non-clustered index, the change isn't there, but if you look in the table itself, that change is there. That is a violation of consistency. This is one of the rules that SQL Server does keep up very, very strongly. Transactions will not leave the database in an inconsistent state. Isolation, the third one. The ideal for isolation is that an ongoing transaction must not be visible to any other user of the database. So if somebody is making modifications within a transaction, those modifications cannot be seen by anybody else, do not affect anybody else's work. The gold standard for isolation here is that it must always appear as if you are the only user of the database, no matter who else is doing what. This is the one that is held up the least. Isolation is in fact one of the 4 ACID properties that you can change on your databases, and the isolation levels. You can turn isolation up and down, so this is the one that is very much variable. Finally, durability. A durable transaction is one that once it commits, those changes are permanent. If the transaction commits and the entire server fails a microsecond later, those changes should still be there on a restart. Durability is very important. Once commit has happened, that change is done. It cannot be undone. This is why the question of how do I undo a set of deletes? The answer is find a backup, because there's no undo button, because durable. Changes must be durable. So let me do a very quick, let me not do a very quick demo. I'll do a very quick demo on the end of the next slide. So transaction type, SQL Server has 3 modes. Auto commit is default. Every single statement in SQL Server is in an auto commit transaction. The transaction automatically starts before the insert update delete runs. The transaction automatically commits as soon as the insert update delete completes. You can't change this. You can't force an auto commit transaction to roll back. It'll roll back if it throws an error, but by default, every single statement is within its own transaction. You can kind of see this if you look in the transaction log, but it's not very visible anywhere else. The second one is implicit transactions. This is not a default in SQL Server for a whole bunch of good reasons. This is a default in Oracle, however. One of the big problems we see with people switching between Oracle and SQL Server is not understanding the transactional behavior that SQL Server runs in auto commit mode, but Oracle runs in implicit transaction mode. What this generally results in is SQL Server people who go and work on Oracle forgetting to commit their transactions with all the associated pain and mess of that. But also Oracle people coming to SQL Server, making some changes and then assuming they can roll them back, which they can't because it's in auto commit mode. You can turn implicit transactions on SQL Server. It's a connection level setting, which means you can enable it for your connection. I very strongly recommend you don't do that unless you know exactly what you're doing and exactly why you're doing it. Because with implicit transactions on, the first statement that needs a transaction starts one. The first insert update delete you run starts a transaction. It does not automatically commit at the end of that statement like auto commit mode does. The next statement that needs a transaction, well, there's already one there, so it just enlists in that transaction and carries on running. But the side effect of that is if you don't explicitly run commit you've got an uncommitted transaction, and you've got a whole pile of data changes which are not part of the persistent database state, and you've got a whole pile of interesting other consequences. The transaction log grows, locks grow. You can actually take a system down this way, and I've seen people do it. There was an individual on Slack, on the SQL Server Slack the other day, noting that early in his career he had turned implicit transactions on while doing some data modifications on a production system, not because he understood what it did, but because he had read a blog post saying that it was a good idea to do so. And about 4 hours later, the boss comes in and says, I don't know what's going on with the system, nobody can work. Everything's locked solid, nothing is running, we don't know what's going on. The individual in question very quietly ran commit, realizing what he had done, and everything suddenly went back to normal. That's the danger of implicit transactions, because we're not used to that behavior in SQL Server, where you don't need to start the transaction, you do need to commit it. It's very easy to get into a very bad situation. Oracle people are completely used to that idea of, I run an insert, I run an update, I run a commit, but on the SQL Server side, we're not. So be very, 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 very careful with implicit transactions if you decide to turn it on for a connection. The third one's the one I'm going to spend the most of this presentation on, explicit transactions. You start the transaction with begin transaction. That transaction has to be explicitly committed or rolled back. So you explicitly start it, you explicitly commit it or roll it back. Okay, so those are the three transaction types. Lastly, before I start doing some demos, transaction guarantees. These come out of the of the ACID properties. If you have a transaction and that transaction commits, all changes made within that transaction are durable. They are part of the persistent database state. They will survive a restart. If your transaction never reaches the commit, this will be a connection terminate or a restart of the server without the commit having been reached, the transaction is automatically rolled back and all changes are undone. So those are the two guarantees. These are from atomicity and the durability properties of ACID. And I'm going to go and break my database a little bit to do some demos. All right. Probably shouldn't show you what I'm running on my machine, but what the hell. All right, so let's see. Let's start with some uncommitted transactions. And I need another window for this, because I always need another window for this. All right, so uncommitted transactions. I have got a very simple database here that has one table in it and no data. See, no data. So my table is empty. So in this one, I've got a begin transaction. I've got two inserts, but note I do not have a commit. There is no commit or rollback. So this is going to leave an uncommitted transaction. If I go and try and query this from another window, I'm actually going to wait forever if I don't do anything, because this is locking. Isolation is enforced with locking in SQL Server by default. I am not allowed to see those rows because they're uncommitted rows that another transaction, another session has created. So I get blocked, and my session actually will sit here forever if I do nothing about it. I don't want to do nothing about it. All right, so the first thing I want to do, this is session 64. Oh, in this session, by the way, I can absolutely see those rows. There are two rows in that table. You can always see your own changes. I am not committing this session. This is session 64. Right, that's a connection terminate. I have killed that connection. The changes were not committed. So if I go back now, I can see that there are no rows in that table. And if I reconnect to the session, I can see there are no rows in this table. My transaction did not commit And so when the connection was terminated, SQL Server Database Engine picks up that there are uncommitted changes made by that connection. That connection has now been terminated, hence it cannot possibly commit those and so those changes are automatically undone. All right, let's have a bit more fun. Let's do this again. All right, this is where I start breaking things because, you're about to learn a command that I do not ever want anybody ever to run on a production server. Please don't do this. That does exactly what it says it does. SQL Server is terminating. Not this process, SQL Server is terminating. I now have a shutdown database. And I actually won't kill that because otherwise I'm going to get some real fun. And where is my connection? I've done the configuration manager before I started, but I didn't think to do that, so whoops. All right, and yes, you can see that my 2019 instance is indeed not running. Let's fix that. This is the slow part of the demo, I'm afraid. Okay, that's now running again. Back to Management Studio. And reconnect all my damn queries. That's always one of the fun of this particular demo. I always end up having to reconnect my queries. At least they're behaving themselves this time. All right, let me kill that. I don't want to run that again. No rows in that table. The transaction had not committed. The SQL Server service failed because I killed it. And so the changes are automatically undone. The changes never persisted. Right, one more demo. Those are both the atomicity, the fact that changes will be automatically undone if the database engine restarts and the transactions are not committed. So one more, I'm going to commit this. Hey. I'm going to kill the server again. No wait literally means that there is no time to do checkpoints or write data to disk or clean up anything. So this should shut down the server before these changes actually get to disk. Because obviously we make changes, when you make changes to tables, those changes are made in memory, they get flushed to disk later. I'm not giving SQL Server time for later. Bye-bye server. Okay. Configuration manager. Okay, one-stop server again. Blah, blah, blah. This is always one of those fun demos. Just need to be careful, otherwise I get Management Studio into a state where it can't quite figure out if the connection's there or not. I've actually had to restart Management Studio before to do that. All right, so wrong database. Let's go put this into transaction demo. One part of I miss of actual physical presentations. Normally when I do this kind of presentation in person, I ask for show of hands. Who thinks this many? Who thinks that many? It's kind of hard to do it here, so I will just instead show you that there are indeed 2 rows in that table. The commit transaction was reached. That commit was written into the transaction log, which means that when SQL Server restarted, that database was then started up. If I can find my parallel redo, started for transaction demo. One transaction rolled forward in database transaction demo. The transaction that I committed and then killed the server afterwards, it didn't have the opportunity to flush the disk properly, and so it had to be rolled forward, replayed when SQL Server restarted. But that change was durable, even though the server shut down immediately after the insert was completed, after the transaction commit was completed, I should say. So that's the basics of transaction guarantees. Do we have any questions? before I start making things more complicated?
There are no questions so far.
There are no questions. Excellent. I hope that means that everybody's following what's happening and not that everybody's, voted off to have lunch.
I think they follow. I do, at least.
Okay. All right, I'm going to do a couple more demos that I don't actually have slides for. I really should fix this presentation. Actually, no, I'm not. I'm going straight into the nested transactions. All right, so nested transactions. Let me start by saying nested transactions do not exist. Nested transactions do not exist in SQL Server, they never have. I have this theory that nested transactions are the SQL Server dev team's joke, and we're the victims. They're playing a long and elaborate prank on us and having a lot of fun over it. Because SQL Server has the syntax for nested transactions, it does not actually have nested transactions, however. If you have nested transactions, and by that I mean multiple begin transactions, one inside the other, you have one transaction, not multiple of them. Because it's only the first begin transaction that actually does anything. The first begin transaction starts the transaction, writes into the transaction log, does all the things that you would expect a transaction to do, and lists in the transaction manager, blah, blah, blah. Anything after that just increments a counter. It does nothing else. Which has the fun impact of the commits later don't actually do anything until the last one is reached. This is best done with a demo because this is the one that usually has people going, oh hell, is that actually how it works? Oh god, I need to fix code on Monday. So I have here some transactions. I actually should truncate my table first, sorry. Let me just be clear, truncate. Let's make very sure there's no data in that, because if there's data in that, it really takes the impact of my demos away when I say there are no rows in this table, and there are actually two left over from a previous demo. All right, so there are no rows in the testing inserts table at this point in time. Okay, so this begin transaction does something. That begin transaction is the outermost transaction, and I should prove that by other things, open tran. There are no active open transactions. This begin starts the transaction, writes into the transaction log, enlists into the transaction manager, does all the other setup for this is now a set of atomic statements, etc., etc. Then insert a row. This does nothing. I may as well have written no op there. Well, not quite. It's not quite that simple. But this transaction, this begin transaction, does not start a transaction because SQL Server does not have nested transactions. So I insert another row. I begin a third. No, I don't begin a third transaction because the SQL Server does not have nested transactions. I run a third begin transaction statement. And I insert a third row. This commit does nothing because it's not the outermost one. This commit does nothing. It's not the outermost one. This commit does the job of committing the transaction, writing the log entries, and enlisting the transaction manager, cleaning up all the logs, etc., etc. That is the commit transaction that actually commits the damn transaction. These ones do sweet absolutely nothing. So let me run this. It's really not very impressive if I run this as it is, because it behaves exactly how you'd expect it to. We will have 3 rows at the end of this query. I should probably put my truncate at the top to make sure I clean up each time. That's easy. Everything goes right. So Let me roll the transaction back in the middle instead. Begin transaction, insert, begin transaction, insert, begin transaction, insert, commit, rollback, commit. Okay, I'm going to try the show of hands things. How many people think there will be 0 rows in that table at the end of that transaction? Hands, please. 2 people think there will be 0. How many people think there will be 1 row? Oh, no, not 0, 2. There were 2 people who said that. How many people think there will be 1 row in this table at the end of this? Yes, anybody? Nobody thinks there will be one row. You guys who are paying attention, thank you. How many people think there will be 2 rows in this? 2 rows? Anybody for 2 rows? Nobody for 2 rows. 3 rows? Anybody think there will be 3 rows? I mean, there's 3 inserts in here. 1 person thinks there will be 3 rows. Thank you for that. Somebody to pick on. There are no rows in that table. I noticed the hand goes down very quickly. I did get the name. It's not fun when I can't walk up to the person who said the wrong things and make them the butt of the next 3 or 4 jokes. There are no rows. There was 1 person. There are no rows at the end of this, because this begin transaction started the transaction. This one did nothing. This one did nothing. This commit did nothing. Oh, but rollback. Rollback behaves differently to commit. Rollback does not get ignored if it is somewhere higher in the transaction list. Rollback anywhere in your nested transactions rolls the transaction back. This last commit then threw an error. The commit transaction has no corresponding begin transaction. No, it's not talking about that one. The commit transaction came along and there was no transaction to commit, so it threw an error. This is the risk of nested transactions. I made hints to a counter. Begin transactions, this one started the transaction, it also set tran count to 1, at tran count to 1. This, the only thing it did was set at tran count to 2. This, the only thing it did was set at tran count to 3. Commit transaction first decrements at tran count and then checks what its value is. If it is 0, it commits the transaction. If it is just decremented to 0, it commits the transaction. If it is decremented it anywhere else, it does nothing. Rollback, however, sets tran count to 0 and undoes the transaction no matter where it is. So think about something more complicated than this. Think about something where you've got begin, create procedure, blah, blah, begin transaction, exec procedure, which has a begin transaction, and exec procedure, which has a begin transaction in it, and your 4 levels of procedure and 3 levels of transaction deep, and something triggers a rollback. What rolls back? Everything. Everything back to the first begin transaction. Nested transactions are a lie. Please don't use them, because this is a little surprise that I promise will blow your code up sooner or later. Are nested transactions.
We do have a question on nested transactions. And it goes, can you error trap the inside transaction failed, manually decrement tran count, and then just skip over it?
No, because there's nothing to catch. Look, if something runs rollback transaction in the middle of this set, it's going to roll back. if you're talking about catching a level 16 error, hold on, there's another demo that you're really going to like in a minute, because user errors, I'll get to that demo in a minute. You might be unpleasantly surprised. If something runs rollback transaction, that's not an error. And it'll undo everything. Imagine that you've got error handling in, procedure number 3, which is 2 levels of transaction down, and that error handling goes rollback transaction. Yeah, that rolls a transaction back. And no, you cannot manually decrement at train count. It's an internal variable. Pause off, you can't touch that. SQL Server doesn't like you playing with the internals of the transaction manager for very good reasons. All right, I normally get a question once I've done this demo about, what about named transactions? Surely if we name them, they behave differently. Oh boy. Oh boy. This is usually the second thing that sends people running to fix their code on Monday. Named transactions are there for documentation purposes and nothing more. And yes, I know that was a very blunt statement to make, but the naming of transactions does not have any effect on transaction behavior. Caveat there, it does, but I'll show you that in a second. It's not in the direction that you probably think it is. So let me go back to my favorite demo and name my transactions. I will be lazy. I don't feel like naming them properly. All right. Oh, this is going to be fun. What should I put on this rollback transaction? Magnus, you may as well tell me, or I'll take somebody can tell me. What should I be putting on this rollback transaction?
Anything you want.
Anything I want. I want to put T2 there.
Yeah.
If this was a more complicated example with nested procedures, that's what would be there. You roll back T2. So, does anybody think this is going to change the results? I mean, we saw that there were 0 rows in that table at the end of the previous demo. So hands up, anybody that thinks that there will be anything other than 0 rows in this table at the end of this demo? Any hands? Any hands at all? I love this demo. It's set up so that everyone gets it wrong. There are 3 rows in that table at the end of that transaction. Why? The why is in the error message. The error message does not read, cannot commit transaction, no open transaction was found. It reads, cannot roll back T2, no transaction of that name was found. Here's another question. Do I have an open transaction at this point?
Maybe it depends on how that error works.
The answer is yes, I do. Because this started a transaction named T1. This incremented a counter. What happened to the name T2? Threw it away because it didn't start a transaction. So it couldn't be given, that name couldn't go anywhere. Begin transaction T3, same thing. That name didn't belong anywhere because it's just a counter. Commit transaction T3. Well, commit doesn't do anything if tran count's not a 1, so that just decremented at tran count. But here's the kicker. Rollback transaction T2. See, rollback can take a name on it, and it's got a very interesting behavior. And rollback looked for transaction T2 and couldn't find it because it doesn't exist, because nested transactions are a lie. And so that rollback failed. At tran count is now 2 because this decremented it. Commit transaction T1. Decremented at tran count from 2 to 1 and did nothing else. My transaction is still open. I love the Microsoft documentation on this point. Let me actually dig up different one. I'll pull this over so you don't see everything else I have running in Firefox. Because you really don't want us to see everything I have running in Firefox. Yes, of course, I want the Microsoft documentation. What else would I want? All right, transaction name. Is the name assigned to the transaction must conform to the rules for identifiers. Use transaction names only on the outermost pair of begin commit or begin rollback statements. Always case sensitive, even when the instance is not. Sweet. Okay, that's begin transaction. Let's look at commit transaction. I love this. This is absolutely fantastic. Is ignored by the SQL database engine. The transaction name on commit is ignored. Name? Utterly hilarious, by the way. If I change this back to commit from rollback and actually roll my transaction back to undo this mess, thank you. The comma won't work. Yeah, I don't have a transaction of that name. It's completely ignored by the database engine. Yay. Specifies a name assigned by a previous begin transaction. No, it clearly doesn't, because it's ignored. Must conform to the rules for identifiers. Cool, can't exceed 32 characters. It's not case sensitive because it's ignored. Great. Rollback transaction. Transaction name is the name assigned to the transaction on begin transaction. When nesting transactions, transaction name must be the name from the outermost begin transaction statement. Always case sensitive. Yay. Not the name corresponding to the outermost begin transaction, your rollback throws an error, leaving your transaction open and uncommitted. I don't even want to think about how much of a mess you're going to have cleaning that up out of your system after that open transaction's gone back into the connection pool for a few hours. This is horrible. Please don't ever do this. Ever. Please do not ever do this. If there's one thing you can take out today, it's this is a disaster. Name your begin transactions if you want to. It's useful because that transaction name shows up in deadlock graphs, it shows up in the DMVs. If I just run this, for example, and then it's active transactions, I think. You see that I've got my transaction name. I just ran that one, by the way. So I can commit T3, it'll be fine. So the name of the outermost begin transaction, the only one that actually exists, goes into the DMVs, it shows up in the deadlock graphs, it shows up in other metrics, it can show up in extended events. So name your outermost begin transaction if you want. Please do not ever name a rollback. Please do not ever put a name on a rollback unless you absolutely know exactly what you're doing and exactly what the consequences are going to be if somebody wraps a transaction around that. Because that's all it takes to blow your code up. You do not want to be fixing this. It is horrible, horrible thing to try and fix. If you'd like to put a name on your commit transaction, put anything you damn well like, because SQL Server completely ignores it. Any questions on naming transactions? You may get a hint that I hate named transactions for a very good reason. I have had to clean this mess up out of systems before.
I've found them useful when I need to do a rollback to a specific transaction.
Nope, that's not how it works. I just showed you that's not how it works. You cannot roll back to a specific transaction. You're thinking save points. You can name a save point and roll back to a save point. But if you name transactions, you cannot roll back one of them.
No, I mean when I do a restore with the transaction log restore, then I can do it to a specific. But we do have a question which is it's not on the nested things or the named ones, but the question reads: if you insert into physical table using table variable, will it be rolled back and only table variable will have data?
A normal table persists is part of all transactions.
Yeah.
So that's an insert into a normal table, regardless of where the data came from. Table variables don't don't take part in user transactions, but that's when you're putting data into them. When you're using them as a source, normal transaction behavior applies. So no. But yes, Magnus, I agree with you. Restore to mark, rarely useful, but when it's useful, it is so useful. But yes, that's a name on a transaction, not a name on a commit or rollback. I've never seen a good reason for a name on anything other than begin tran.
No, true.
All right, I'm definitely taking ages as usual because yay fun. So transactions and locks. You saw that a bit earlier. I took I ran an insert in a transaction and I couldn't access the rows until the end. That's fairly standard locking behavior. I'm not going to go into that a whole lot in this presentation, because that's fairly normal. One thing I will say though is be careful of what's called the read and update pattern. I always end up taking forever on my nested transaction and then running out of time. So this is what I call the read and update pattern. You read a row from a table, do something with it, and then insert it into another, and then do something with it. So I'm getting, this is a manual sequence. I'm getting the highest row from this particular table, waiting 30 seconds in this case just so I can flip windows. I don't need 30 seconds, 10 is actually more than enough. I'm not that slow clicking things. And then inserting max +1 back into that table. This is a really bad idea. I see this all the time in developers' code. But this has a problem. It'd be better if I put it in the right database, wouldn't it? All right, so the problem with this is that there is nothing that is stopping two connections from reading the same data. Shared locks are shared, and multiple connections can read the same row at the same time. It's only the modifications which you get exclusive locking on. So what's going to happen here is that both of these windows are going to get the same value from this table. They're both going to increment it by 1, and they're both going to insert it. So I actually need some setup here first. That's fine. So that's my setup. So 1, 2. Okay, and that one's also finished, yes. And what you see here is that I have the same value from both of those queries. This is definitely a little bit of a problem. There's a lot of people, I've seen a lot of code like this that seems to assume that inside a transaction, nobody else can read what you're reading. Not true at all. Multiple things can read, only one thing can write. The lock goes on the exclusive lock is on the write, not the read. Plus, on default isolation level, that lock on the insert from the select is dropped as soon as that statement completes. So anytime you're fetching data from a table, doing something with it and inserting something else somewhere else, or updating somewhere else, or deleting somewhere else, stop and think about what happens if 4 sessions do that first thing at the same time. Are you going to have data inconsistencies? The answer is probably yes. I normally, for this presentation, go through people's suggestions from the audience as to what you need to fix this. I'm obviously not going to do that here because the virtual makes it a lot harder. I will tell you, however, that you need essentially a tab lock X. About the only thing that makes this work is I know, horrible. Lesser locks cause either deadlocks or incorrect data. Pick one, or both. Sometimes you get both, which is great fun. You get deadlocks and you get incorrect data. I'll find a blog post I wrote on this and put it in chat for anyone that wants. But yeah, so any questions on the locking? I know I rushed through that a bit. I apologize for that.
Nope, nothing.
Yep, home built sequence columns. That's what I was looking for. One of them. So you can dig into. That's interesting. Chat is taking forever to load for me. And then there's that one as well. Yeah, I can't get chat to load. I don't know why. I'll might as well do is I'll send these to you later. These two links. So insert code, that's your insert update pair, and then home built sequence columns. Those are the two cases I most commonly see people trying that fall into this read then update trap.
I'll put those into the. If you click on past sessions on SQL Friday, I will put them in the beginning of the description of the session so that you can follow the links, people.
Cool. All right. So transactions and errors. I previously mentioned that if you've got a transaction and it doesn't reach the end, it automatically rolls back. From that, people tend to assume that if a statement in a transaction throws an error, the transaction rolls back. And the earlier question we got about can you trap for errors seem to assume that as well. Oh boy, you're going to have fun with this demo. This is the third thing that sends people running to fix their code on Monday. This and that. I don't need those two. All right, let me truncate my table again. Okay, so one insert statement that'll succeed. One insert statement that will throw an error. You can't divide by 0. It's very simple, divide by 0. Nothing fancy there. One insert that will succeed. One commit transaction. I would like, please, as a show of hands from the audience. No, that was not what I meant to do. That was what I meant to do. Who thinks there will be 0 rows in this table at the end of this particular set of queries? I am truncating it beforehand. There are 0 when it starts. So how many when it ends? Anybody think 0? Nobody thinks 0. Who thinks 1 row? Nobody thinks 1 row. Okay. Who thinks 2 rows? 1 person. 2, 3. Oh, lots of people. Okay, so you guys know this one. All right. 5 people. Think 3 rows? I'd love to know how there would be 3 rows in this table, but anyone think 3 rows? I'm not sure if you guys just haven't put your hands down or if you're actually saying.
I think that's just hands not being taken down.
Yeah, I think so too. Okay, nobody thinks 3 rows because it would be kind of hard to get 3 rows when only 2 of those inserts are going to succeed. All right, well, in this case, the majority is definitely awake because there are 2 rows in that table. Because there's nothing about this that forces a rollback. This is a insert that row, insert that row, insert that row, and then commit the transaction. And if the row in the middle failed, well, they're too bad. User errors do not trigger transaction rollbacks. If you want this to roll back, you have to wrap it in error handling. You have to either set exact abort on, which will cause the transaction to automatically roll back as soon as an error occurs. That's not default, by the way. Exact abort on is not the default. Not in .NET, not in JDBC, not in Management Studio, anywhere that I've seen. So if you turn exact abort on, there will be 0 rows in that table at the end of that transaction because this one will throw an error and will abort the transaction. So this is one way of doing it. This is the second way of doing it with a try-catch block. Try catch and manually roll the transaction back. Please roll it back before you throw, not the other way around, because otherwise you end up throwing an error with an open transaction associated with it. You really don't want to be throwing open transactions around your system. But one of the 2 has to be done. But as I said, by default, a user error that is severity 16 does not terminate a transaction. To terminate a transaction, you need 19 or higher. And most of the time you are not throwing 19 or higher errors from your user code. Okay, so any questions on?
There is an excellent question because you already answered it. Does it depend on the severity of the error? So yeah, level 19
or higher will automatically roll the transaction back. However, 19 and higher will also automatically terminate your session. And 19 or higher are things like the server room's on fire. It's not I divided by 0. No,
what happens if you do something that is causing the transaction to be doomed? Like, I know that if you do an illegal convert with a date time, that's going to doom the transaction.
Yep. Only if you catch it. It'll still. I've seen some which can still commit, even though, yeah, it's really weird. There's only a couple of things which actually doom the transaction. I think most of them are around foreign keys. Oh, by the way, this is a rule that breaks, by the way. I said user errors do not automatically roll transactions back. There are, of course, exceptions to that, about 6 or 7 of them that have to do with foreign keys. Yay, because consistency is not one of SQL Server's big advantages, at least not consistency around how it behaves. It keeps its database consistent, but its behavior is utterly weird. So yeah, there are a couple of cases, and I accidentally found one in a previous demo. I changed the type of error I was throwing, and suddenly my transaction automatically rolled back. And so that's not how it behaves. But it's not usually how it behaves. What is that? But yes, most user errors will not roll back the transaction back, unless you're playing with DDL, in which case anything is possible. I tried once writing up what the exceptions were. I gave up. It was just too, no. So how do you handle transactions and errors? Option 1 is exact abort. Okay. Nope. Only these. So option 1 is exact abort. Option 2 is the try catch block. I definitely prefer try catch. It gives me more control over my errors. But if all you want is your transaction to roll back if an error happens, just turn exact abort on. It'll do the job. If you are going to do it manually, try catch. Rethrow the error, log the error. Please don't just swallow the error. My favorite piece of code I got out of a grad class last year was this. There's nothing like failing silently. Because I can run that as many times as I like, and the data will never go into that table, and SQL will never tell me why. This, by the way, will help if I was in the right database, of course. By the way, you can't catch syntax errors like missing tables. Yay! 1 row affected, 0 rows affected. Success. Nothing like success that does, yeah. Please don't do this to yourselves. This sucks. I've done that. All right, caveats, because there have to be of these. Page splits, identity column increments, sequence increments, these do not roll back, even if they are explicitly rolled back. Internal operations typically don't. So if you, for example, insert into a table that's got an identity column and then roll back that insert, the identity still increments. How do you fix that? You don't. You can't affect that. Don't use identities if a gap is a problem. Table variables, as we noted earlier, don't participate in user transactions. All that means is if you're doing inserts, updates, deletes into the table variable, and you roll back the transaction, the table variable is unaffected. Everything around it is still affected. The permanent tables, the temp tables, they're all affected. The table variable is not. This is actually really useful, though. You can log errors into the table variable, roll the transaction back, and you've still got all your errors. So that is really, really handy. This is not a flaw, this is by design. Delayed durability, which was added in 2014, allows for committed transactions to be lost on a restart. Yay. This literally does what it says, and it delays the durability. So a commit transaction returns successful before the log records are written. So you can actually lose a committed transaction. Be very careful if you're turning this on, be aware of that. It's really useful, but under some circumstances. And then, of course, there are some errors which do automatically roll transactions back, of course, because what would life be without the exceptions? They are mostly DDL related. As I said, foreign keys are notorious for this one. But if you're playing with DDL, the rules tend to break slightly. Yay. Okay, so in conclusion, I think I have 3 minutes because I'm pretty sure I have another meeting at 1 o'clock. Lunch would have been really nice, but apparently not today. Transactions are a way to get multiple data modifications to be treated as if they are a single operation. If your transaction does not commit and the connection is terminated, that transaction automatically rolls back. If SQL Server terminates before a transaction commits, that transaction automatically rolls back. User level errors do not cause transactions to roll back unless you turn exec abort on. Nested transactions are a lie. Please do not name your transactions unless you know what you're doing. If you're going to name your transactions, please do not name your commits or your rollbacks. Naming your transactions is fine, it's documentation purposes, with the exception of the with mark and the restores. Please do not ever put a name on a rollback. This is a flippin' little hidden bomb in your code that is only waiting for someone to wrap a transaction around it to go off. Please do not do that to yourself. All right, I have some references, if I can find them. So the demos are up on GitHub. The database, yeah, the whole lot of demos are there. You can go and grab them. I wrote a series on transactions, including nested transaction, named transactions, save points. The concurrency is hard is that upsert code, I need to put the manual sequences into this list of resources as well, but I'll send that on to Magnus. Cool, so that is it for me and transactions for today. Any questions?
No, no more questions. No. Not even from me.
Okay, I'm curious. Is anybody going to fix code on Monday because of something they found out today?
Fortunately not.
I
think I caught it.
My unbroken streak of fixing code still exists. Anil, if you're willing to tell me, what is it that you need to go fix?
We will see if there is anything.
People often don't like admitting to that. I'm fine with that. Probably either nested transactions or named transactions would be my guess. Those are usually the ones that catch people out. Awesome. Well, thanks, Magnus. That was
cool.
Fun.
Thank you so much for coming.
I will go to my other meeting now. Yay.
Yeah, I have one starting 1 o'clock too. So that's basically now.
I have a feeling we're going to the same meeting.
All right. I will see you.
Thanks very much.
Thank you.
See you around. Cheers.
Bye.